Welcome. In this video, we are going to introduce Lewis dot symbols and talk about what they are and practice drawing Lewis dot symbols for individual elements. So first, let's start with what we know. We are familiar with these things called structural formulas over here on the left. This is a structural formula for CH4, and we see 4 lines in the structural formula. Each line represents a covalent bond. And a covalent bond, like what's occurring in a covalent bond is that the atoms are sharing electrons. And specifically, each bond represents 2 shared electrons. So every line you see in a structural formula represents 2 shared electrons. And we can use dots to represent the electrons rather than lines. And when we do this, we call this a Lewis dot structure. So in a Lewis dot structure, we use dots to represent electrons. So here you can see that like this carbon and this hydrogen atom are sharing these 2 electrons between them. And then this carbon, this hydrogen are sharing these 2 electrons. So each covalent bond represents some shared electrons. The Lewis dot structure is showing those electrons and how they're being shared. So let's talk about how to draw Lewis symbols for elements. So the steps here, first what you're going to do is you're going to look on a periodic table to determine how many valence electrons the element has. So you might remember we observed this pattern in the periodic table that there's a relationship, sorry, it's my very messy version here, between the column that an element is in and how many valence electrons it has. So over here on the left, all of these in column 1 have 1 valence electron, these ones have 2 valence electron, then 3, 4, etc. There's a pattern there. So we're going to look at the periodic table, figure out how many valence electrons the element has. And the number of valence electrons can equal the number of dots. So each dot represents a valence electron. And then pretend that you're going to draw the symbol for the element, and then pretend like it's a square with 4 sides. And you're going to put 1 dot on each side of the symbol. So what that means is, let's say I'm looking up, carbon, and I want to draw the Lewis dot structure for carbon. I'm going to look on a periodic table. Let me look right here. Here is carbon on the periodic table. It is in column 4A. So that means carbon has 4 valence electrons. So it's going to have 4 dots. And so I'm going to write down the symbol for carbon, which is the letter C. And then I'm going to treat this symbol as if it were a box. That makes sense, with 4 sides. And I'm going to put 1 dot on each side. 1, 2, 3, 4. If I have 5 or more electrons, then I'm going to start doubling up. You will never have more than 2 electrons per side. So let's look at an example of this. If you look at nitrogen, nitrogen is right here. It is in column 5. So it's going to have 5 valence electrons. Sorry about that. It's going to have 5 dots in the structure. So I'm going to write down the symbol for nitrogen, which is N, and then I'm going to treat this symbol as if it were a box. And since it's going to get 5 valence electrons, that means it's going to have 5 dots. And I'm going to put 1 dot on each side, 1, 2, 3, 4. And then I'm going to start pairing up electrons. If I've got 5 or more, I'm going to end up with a pair of electrons on at least one side. So you have 2 electrons together, we call that a pair. Okay, so these are the general steps for how we draw a Lewis dot symbol for an individual element. So look on the periodic table, figure out how many valence electrons it has. The number of valence electrons can equal the number of dots. You put 1 dot on each side, and if you've got more than 4 electrons, then you can start pairing those electrons up. But you will never have more than 2 electrons per side max. Okay, so now let's try some practice. We've got these symbols. I'm going to draw the Lewis dot symbols for these elements. So the first 2 are ones we already did on the previous page. So we saw that carbon looks like this, and nitrogen looks like this. So let's try a couple more together. So if we look at oxygen, oxygen is right over here. It is in column 6. So that tells me that oxygen has 6 valence electrons. So we're going to have 6 dots, because each dot represents a valence electron. And I'm going to put 1 on each side. So 1, 2, 3, 4. And then if I have more than 4, I'm going to start pairing up. So my 5th and 6th electrons are going to form pairs. So again, that language here, we refer to these as electron pairs because they're doubled up here in a pair. And we'd say that these ones are unpaired electrons. And it turns out that becomes really important later for bonding, whether the electrons are paired or unpaired. So that's why we want to pay attention to that right now. Let's look at fluorine, element F. It is right here. Notice how we're kind of going down the line on the periodic table. And fluorine is in column 7. So that means it has 7 valence electrons. And so it's going to have 7 dots. So I'm going to start on one side. I'm going to go 1, 2, 3, 4, 5, 6, 7. So we'll notice that fluorine has 3 pairs of electrons and then 1 that is unpaired. And now let's look at neon. Neon's over here. It is in column 8. That's the most valence electrons anything can have is 8. The numbers don't get any higher than that. So it's got 8 valence electrons and 8 valence. And then we would go 1, 2, 3, 4, 5, 6, 7, 8. Notice that neon has no electrons that are unpaired. Okay. And the other thing you'll notice, if we go to the second row, silicon, phosphorus, sulfur, chlorine, we will notice that these elements are all just right below those other elements we already drew. So silicon, like carbon, also has 4 valence electrons. So if it has the same number of valence electrons, it's going to have basically the same Lewis dot structure. So we'll find here that things that are in the same column on the periodic table have the same valence electrons. Therefore, they're going to have the same Lewis dot structure. And we know that that things on the same column have similar properties. That's something that we learned earlier on. That's why we give them names like the noble gases and the halogens, is because things in the same column tend to behave similarly. So again, we're noticing a relationship between the valence electrons and the periodic table and how elements behave. So these valence electrons are really important in telling us how these atoms are going to react. Okay, so same thing, we'll look at one more, like phosphorus is right below nitrogen. So phosphorus also has 5 valence electrons. So its Lewis dot structure is going to look just like nitrogen. So again, that's a pattern you will notice. Things in the same column have the same valence electrons, so you're going to have similar Lewis dot structures there. So that is how we draw a Lewis dot symbol for an individual atom. Thanks for watching. Let me know if you have any questions.